Classical physics is the branch of physics that should be described by classical notions, which define emergent phenomena. An emergent phenomenon is a property that is a result of simple interactions that work cooperatively to create a more complex interaction. Physically, simple interactions occur at a microscopic level, and the collective result can be observed at a macroscopic level. The developed Hypersphere World-Universe Model introduces classical notions when the very first ensemble of particles was created at the cosmological time about 10 to the minus 18 seconds, and become possible to introduce the notion medium of the world. In WUM, space, time, gravity, temperature, mass are all emergent phenomena. There is a basic size unit about 10 to the minus 14 meters in classical physics, no less. We emphasize that classical physics is principally different from quantum physics that describes quantum objects which have four momenta only. Classical physics is dealing with ensembles of quantum objects. According to contemporary physics, classical physics, pre-1900 physics, is a group of physics theories that predate modern, more complete, or more widely applicable theories. Modern physics, post-1900 physics, incorporates elements of quantum mechanics and relativity. How classical physics can incorporate elements of quantum mechanics in modern physics? I don't get it. To be clear, I would like to provide a couple examples. Kinetic theory of gases explains microscopic properties of gases, such as pressure, temperature, viscosity, thermal conductivity, and volume, by considering their molecular composition and motion. In 1859, Maxwell formulated the Maxwell distribution of molecular velocities, which gave the proportion of molecules having a certain velocity in a specific range. This was the very first ever statistical law in physics that defines macroscopic properties of gases as emergent phenomena. The temperature of the ideal gas is proportional to the average kinetic energy of its particles. The temperature knows nothing about movement of each particle, and particles have kinetic energies only. They have no idea about the temperature. In 1965, Penzias and Wilson discovered cosmic microwave background radiation. According to Big Bang model, about 380,000 years after Big Bang, temperature of the universe fell to the point where nuclei could combine with electrons to create neutral atoms. As a result, photons no longer interacted frequently with matter. The universe became transparent, and MBR was created. The photons that existed at that time have been propagating ever since, though growing fainter and less energetic, since the expansion of space causes their wavelengths to increase over time. These photons are the same photons that we see in MBR now. But then, why is MBR is perfect black body? What is the mechanism of photons' wavelengths increasing over time and growing fainter and less energetic? According to WUM, wavelengths is a classical notion. Photons, which are quantum objects, have four momenta only. They don't have wavelengths. By definition, black body radiation is thermal electromagnetic radiation within or surrounding a body in thermodynamic equilibrium with its environment. Black body spectrum of MBR is due to thermodynamic equilibrium of photons with the intergalactic plasma, the existence of which is experimentally proved by fast radio bursts. Space and time. There is no doubt that we cannot develop any scientific concept about the physical world without establishing a primary idea of space and time. Newton's primary notion of space and time is documented in his Principles of Mathematics. Euclidean space is a fundamental space of geometry intended to represent physical space. Originally, it was a three-dimensional space of Euclidean geometry. Minkowski space is a combination of three-dimensional Euclidean space and time into a four-manifold where the space-time interval between any two events is independent of the internal of inertial frame of reference in which they are recorded. Although initially developed by Minkowski for Maxwell equations for electromagnetism, a mathematical structure of Minkowski spacetime was shown to be implied by the postulates of special relativity, because it treats time differently than it treats three spatial dimensions. Minkowski spacetime differs from 4D Euclidean space. In WUM, the world is a hypersphere of 4D nucleus of the world, which is in fact a 4D bubble with a low density in the present epoch. It is expanding in its fourth spatial dimension. As a result, the hypersphere is evenly stretched. All points of the hypersphere are equivalent. There are no preferred centers or boundaries of the world. A hypersphere is an example of three-manifold, which locally behaves like a regular Euclidean 3D space, just as a sphere looks like a plane to small enough observers. 3M finite boundless world has a spatial measure, radius of the curvature in the fourth spatial dimension R. All spatial parameters of the world can be measured relatively to R. Any cosmological model of the infinite universe has no spatial measure. WUM introduces absolute cosmological time tau measured from the beginning of the world 14.22 billion years ago, like the absolute temperature T measured from the absolute zero in kelvins. It is principally different from the solar time T, which is defined by the parameters of the solar system, and cosmic time of the general relativity. It is defined by the impedance, wave resistance, of the medium that equals to the Hubble's parameter H. Cosmological time equals to inverse value of H. It marches on at constant pace since the beginning of the world until the present epoch, and defines the age of the world according to this equation. All time varying parameters of the world can be measured relatively to the absolute age of the world. Time is not a physical dimension in the absolutely different entity than space. Time is a factor of the world. In our everyday life, we use an alleged space 3D Euclidean and solar time T. Medium of the world. Timeline of luminiferous ether. 17th century, Robert Boyle was a proponent of an ether hypothesis. According to Boyle, the ether consists of subtle particles, one sort of which explains the absence of vacuum and the mechanical interactions between bodies, and the other sort of which explains phenomena such as magnetism and possibly gravity that are otherwise inexplicable on the basis of purely mechanical interactions of macroscopic bodies. Say 1690, Huygens' treatise on light theorized that light is a wave propagating through ether. 1704, Isaac Newton publishes Optics, in which he proposes a particle theory of light. This had trouble explaining diffraction, so he adds a fudge factor, claiming that an ethereal medium is responsible for this effect. and going further to suggest it might be responsible for other physical effects such as heat. 1727, James Bradley measured stellar aberration for the first time, proving that light has a finite speed as well as that the Earth is moving. 1818, Augustin Fresnel introduces the wave theory of light, which proposes light is a transverse wave traveling in an ether, thereby explaining how polarization can exist. It is important to note that both Newton's particle theory and Fresnel's wave theory both assume an ether exists, albeit for different reasons. From this point on, no one even seems to question its existence. 1904, Hendrik Lorentz publishes a new theory of moving bodies without discarding the stationary electromagnetic ether concept. 1905, Henri Poincaré shows that Lorentz's theory fulfills the principle of relativity and publishes the Lorentz transformations. His model was still based on Lorentz ether, but he argues that this ether is perfectly undetectable. 1905, Albert Einstein publishes an observational equivalent theory, but complete with a derivation from principles alone, leaving the ether aside. Einstein also emphasized that this concept implies the relativity of space and time. He later labeled it special relativity. Following the work of Young and Fresnel, it was believed that light propagates as a transverse wave within an elastic medium called luminiferous ether. At that time, it was realized that ether could not be an elastic matter of an ordinary type that can only transmit longitudinal waves. Unique properties of ether were discussed by McCulloch in 1846, who proposed a theory of rotationally elastic medium. The potential energy of deformation in such a medium depends only on the rotation of the volume elements and not on their compression or general distortion. This theory produces equations analogous to Maxwell equations. McCulloch's ether can transmit transverse waves. He has this to say about the ether. The constitution of the ether, if it ever would be discovered, will be found to be quite different from anything that we are in the habit of conceiving. Though at the same time very simple and very beautiful. An elastic medium composed of points acting on each other in the way supposed by Poisson and others will not answer. Luminiferous ether was abandoned in 1905 by special relativity. The Friedmann equations were first derived in 1922 from Einstein's field equation for the Freeman-Lemartrier-Robertson-Walker matrix and a perfect fluid with a given mass density ρ and pressure P, which is a medium of the universe. The medium exists or not? It turned out that abandoning the luminiferous ether was crucial for classical physics. It is a great pity that the mainstream physicists at that time didn't know or forgot a theory developed by McCulloch in 1846. In later years, there have been classical physicists who advocated the existence of ether. Nikola Tesla declared in 1937 in prepared statement on the 81st birthday observance, all attempts to explain the working of the universe without recognizing the existence of the ether and the indispensable function it plays in the phenomena are futile and distant to oblivion. Paul Dirac stated in 1951 in article Is there an ether that we are rather forced to have an ether? WM is based on Maxwell equations, and McCulloch's theory is a good fit for the description of the medium. The model introduces the medium of the world composed of stable elementary particles, protons, electrons, photons, neutrinos, and universe-created particles. The existence of the medium is a principal point of WM. It follows from the observations of intergalactic plasma, MBR, far-infrared background radiation. According to WM, intergalactic voids discussed by astronomers are in fact examples of the medium at its purest. The medium is the absolute frame of reference relative to MBR rest frame. The Milky Way galaxy and the Sun are moving with the speed of 552 and 370 kilometers per second, respectively. Then there is no need in frames of reference of special relativity. The total energy density of the medium is 2/3 of the total energy density of the world in all cosmological times. All macro objects are built from the same particles. The energy density of macro objects adds up to 1/3 of the total energy density throughout the world's evolution. Medium of the world is the savior of classical physics. Don't throw the baby out with the bathwater. Dark matter. The history of dark matter can be traced back to at least the end of the 18th century. In 1783, John Michel was the first to propose the existence of dark stars. He suggested that there might be many dark stars in the universe and proposed that astronomers could detect dark stars by looking for star systems which behave gravitationally like two stars, but where only one star could be seen. It was an extraordinary accurate prediction of binary systems in which a dark star and a normal star orbit around their center of mass. Bertone and Hooper in 2018 provide an excellent review of dark matter history. In 1844, Bessel argued that the observed proper motion of the stars Sirius and Procyon could only be explained by the presence of faint companion stars influencing the observed stars through their gravitational pull. In 1904, Lord Kelvin was among the first to attempt a dynamical estimate of the amount of dark matter in Milky Way. His argument was simple yet powerful. If stars in Milky Way can be described as a gas of particles acting under the influence of gravity, then one can establish a relationship between the size of the system and the velocity dispersion of the stars. Henri Poincaré was impressed by Lord Kelvin's idea of applying the theory of gases to the stellar system of Milky Way. In 1906, he explicitly mentioned dark matter and argued that since the velocity dispersion predicted by Kelvin's estimate is of the same order of magnitude as that observed, the amount of dark matter was likely to be less than or similar to that of visible matter. Universe-created matter. In WUN, dark matter is dark when astronomers observe the world with telescopes only in the visible spectrum. The contemporary astronomy allows us to observe the world in wavelengths from radio waves up to gamma rays. Then they are not dark at all. The first known binary system was Cygnus X1, 1971, that is typically the brightest persistent source of hard X-rays with energies up to 60 kiloelectron volts. In 2000, Minchin et al. Discovered binary galaxy system where the HI-21 with NGC 4254, which has a 21 centimeter emission. Bohm proposes multi-component universe-created matter system consisting of two couples of co-annihilating UC particles, a heavy UC fermion, UCF1, with rest energy 1.3 tera-electron volt, and a light spin zero boson Dirac 70 mega-electron volts, that is a dipole of Dirac's monopoles with charge mu E slash 2 alpha. E is the elementary charge, and alpha is a dimensionless Rydberg constant that we will discuss below. A heavier fermion UCF2, 9.6 giga-electron volts, and a line spin zero boson LOP, 340 kilo-electron volts, that is a dipole of preons with electrical charge E slash 3, UCF3, 3.7 kilo-electron volts, UCF4, 0.2 electron volts, and at last boson Xion, 5.3 micro-electron volts. The reason for this multi-component UC matter system was to explain the diversity of very high energy gamma ray sources in the world, the diversity of UC matter cores of macro objects of the world, superclusters, galaxies, and extrasolar system, which are fermion compact objects, and UC matter reactors in WUM. UC particles do not possess an electric charge. Their masses cannot be directly measured by mass spectrometry. Hence, they can be observed only indirectly. The signatures of UC particle self-annihilation with expected rest energies from 1.3 tera-electron volt to 5.3 micro-electron volt are found in spectra of diffuse gamma ray background and the emissions of various macro objects in the world. We connect observed gamma ray spectra with the structure of macro objects, nuclei, and shells compositions. Self-annihilation of those UC particles can give rise to any combination of gamma ray lines. Thus, the diversity of very high energy gamma ray sources in the world has a clear explanation. Gravity. In 1687, Newton published a groundbreaking book called Mathematical Principles of Natural Philosophy, in which he described gravitation as a universal force and claimed that the forces which keep the planets in their orbits must be reciprocally as the squares of their distance from the centers about which they revolve. Lesage's theory of gravitation is a kinetic theory of gravity originally proposed by Fatio in 1619 and later by Lesage in 1748. The theory proposed mechanical explanation for Newton's gravitational force in terms of streams of tiny unseen particles, which Lesage called ultramundane corpuscles, impacting all material objects from all directions. According to this model, any two material bodies partially shield each other from the impinging corpuscles, resulting in a net imbalance in the pressure exerted by the impact of corpuscles on the bodies, tending to drive the bodies together. Lesage proposed quantitative estimates for some of the theory's parameters. He called particles ultramundane corpuscles because he supposed them to originate beyond our known universe. It was a genius prediction of universe-created particles, xions, in WUM. The distribution of ultramundane flux is isotropic, and laws of propagation are similar to that of light. He suggested that the ultramundane corpuscles might move at the speed of light. To maintain mass proportionality, ordinary matter consists of cage-like structures in which their diameter is only the 10 millionth part of their mutual distance. So the particles can travel through them nearly unhindered. In order to achieve exact mass proportionality, as in Newton's theory, the ultramundane flux must be infinitely intense. Such a theory is the very first theory which defines the gravity as an emergent phenomenon. In WUM, the time-varying gravitational parameter G is proportional to the energy density of the medium. It is not a constant. This is why WUM aligns gravity with Lessage's theory of gravitation. WM gives for Lessage's theory the following parameters. Xions, 5.3 microelectron volts, are ultramundane corpuscles which created by the universe. Xions are ultra-relativistic UC particles. Proposed weak interaction between xions and matter provides mass proportionality. Energy density of xions in the world, about 64% of the total density, provides high intensity of their flux. Gravitational mass mg is a classical notion that defines gravity, the emergent phenomenon. We emphasize that an inertial mass mi, that is a coefficient of proportionality between a force and acceleration, has nothing to do with mg. Albert Einstein developed his general relativity starting with the assumption that the inertial and passive gravitational masses are the same. This is known as the equivalence principle. In WUM, gravity is not an interaction, but a manifestation of the medium. Emergent gravity, space, and time. Barcelo et al. In 2011 have this to say about emergent gravity. One of the more fascinating approaches to quantum gravity is the suggestion, typically attributed to Sakharov, that gravity itself may not be fundamental physics. Indeed, it is now a relatively common opinion that gravity, and in particular the whole notion of space-time and space-time geometry, might be no more fundamental than fluid dynamics. The word fundamental is there used in a rather technical sense. Fluid mechanics is not fundamental because there is a known underlying microphysics, that of molecular dynamics, of which fluid mechanics is only the low energy, low momentum limit. In WM, the medium of the world is not fundamental and has macroscopic parameters like in fluid mechanics, impedance, gravitomagnetic parameter, energy density, etc. Time and space are closely connected with medium's impedance and gravitomagnetic parameter. It follows that neither time nor space could be discussed in absence of the medium. The gravitational parameter G, that is proportional to the medium's energy density, can be introduced only for the medium filled with matter. Gravity, space, and time are all emergent phenomena. WM confirms the supremacy of matter, postulated by Albert Einstein. When forced to summarize the theory of relativity in one sentence, time and space and gravitation have no separate existence from matter. Maxwell equations. Maxwell equations form the foundation of classical electrodynamics. Gravitomagnetism is a gravitational analog of electromagnetism. Gravitomagnetism equations, different from Maxwell equations by some constants, were first published by Heaviside in 1893 as a separate theory expanding Newton's law. Gravitomagnetism is an approximation to Einstein's gravity equations in the weak field limit. Turing pointed out this analogy in his On the Formal Analogy Between the Basic Electromagnetic Equations and Einstein's Gravity Equations in a first approximation paper published in 1918, shortly after the first paper of Einstein. The value of Maxwell equations is even greater because Swain showed that linearized general relativity admits a formulation in terms of gravitoelectric and gravitomagnetic fields that closely parallels the description of the electromagnetic field by Maxwell equations. We emphasize that gravitomagnetism considers not only interactions between masses, but also between mass currents, which produce gravitomagnetic field. In 2021, Ludwig, in the article Galactic Rotation Curve and Dark Matter According to Gravitomagnetism, wrote, most theories used to explain the rotation curve have been restricted to the Newtonian potential framework, disregarding the general relativistic corrections associated with mass currents. The effects attributed to dark matter can be simply explained by the gravitomagnetic field produced by the mass currents. The explanation of galactic rotation curves made by Ludwig is in a good agreement with WUM. Fundamental physical constants. Maxwell equations were published by Maxwell in 1861. He calculated the velocity of electromagnetic waves from the value of an electrodynamic constant C, measured by Weber and Coleridge in 1857, and noticed that the calculated velocity was very close to the velocity of light measured by Fizeau in 1849. This observation made him suggest that light is an electromagnetic phenomenon. We emphasize that C in Maxwell equations is the electrodynamic constant, but not the speed of light in vacuum. It is worth noting that the speed of light in vacuum, commonly denoted as C, is not related to the world in our model, because there is no vacuum in it. Instead, there is the medium of the world consisting of stable elementary particles. Rydberg constant R infinity is a physical constant relating to atomic spectra. The constant was arose in 1888 as an empirical fitting parameter in the Rydberg formula for the hydrogen spectral series. Electron charge to mass ratio E/me is a quantity in experimental physics. It bears significance because the electron mass cannot be measured directly. The E/me ratio of an electron was successfully measured by Thomson in 1897. We name it after Thomas, RT. Planck constant H was suggested by Max Planck in 1901 as a result of investigating the problem of black body radiation. He used Boltzmann's equation from statistical thermodynamics that shows the relationship between entropy S and the number of ways the atoms or molecules of a thermodynamic system can be arranged. Kb is the Boltzmann constant. Based on the experimentally measured values of these constants, R infinity, RT, CR, and the magnetic constant mu0, we make measurable the most important constant as follows. Basic size units, it used all these experimentally measured parameters that equals about 10 to the minus 14 meters. Dimensionless Rydberg constant alpha, electron rest energy, elementary charge E. All these fundamental constants, including classical electron radius A0, could be calculated based on the experimentally measured constants before quantum physics. It is worth noting that the constant alpha was later named fine structure constant. In WUM, we introduced the following basic units: size, time, energy, surface energy density, based on these fundamental constants. Dirac large number hypothesis. In 1937, Paul Dirac, in the paper A New Basis for Cosmology, said, "It is proposed that all the very large dimensionless numbers which can be constructed from the important natural constants of cosmology and atomic theory are connected by simple mathematical relations involving coefficients of the order of magnitude unity. The main consequences of this assumption are investigated, and it is found that a satisfactory theory of cosmology can be built up from it. The gravitational constant will be inversely proportional to the epoch." WUM follows the idea of time-varying G and introduces a dimensionless time-varying quantity Q that is in effect the Dirac large number, which in present epoch equal to about 10 to the power 40. G can be calculated from the value of the parameter Q. According to these equations, WM holds that there indeed exist simple mathematical relations between all primary cosmological parameters that depend on Q: Newtonian parameter of gravitation, age of the world's radius of curvature in the fourth spatial dimension, Hubble's parameter, critical energy density, concentration of intergalactic plasma, minimum energy of photons, temperature of the microwave background radiation, temperature of the fine infrared background radiation peak. In frames of WUM, we calculate the values of these primary cosmological parameters, which are in a good agreement with the latest results of their measurements. Creation of matter. In 1964, Hoyle and Narlikar offered an explanation for the appearance of new matter by postulating the existence of what they dubbed the creation field. In 1974, Paul Dirac discussed continuous creation of matter by additive, uniformly throughout space, and multiplicative mechanism proportional to the amount of existing matter. WM. The 3M world, which is a hypersphere of 4D nucleus, was started by a fluctuation in the eternal universe. 4D nucleus is expanding in its fourth spatial dimension, and its surface, the hypersphere, is evenly stretching. The radius of the nucleus, r, is increasing with the speed c, gravitodynamic constant, for the absolute cosmological time tau from the beginning, and equals to r equals c tau. The surface of the nucleus is created in a process analogous to sublimation. Continuous creation of matter is the result of this process. Sublimation is a well-known endothermic process that happens when surfaces are intrinsically more energetically favorable than the bulk of a material, and hence there is a driving force for surfaces to be created. UC matter is created by the universe in the 4D nucleus of the world. UC particles carry new UC matter into the 3M hypersphere world. Ordinary matter is a byproduct of UC particle self-annihilation. Consequently, a matter-antimatter asymmetry problem discussed in literature doesn't arise, since antimatter does not get created by UC particle self-annihilation. By analogy with 3D ball, which has a two-manifold sphere surface that has surface energy, we can imagine that 3M hypersphere world has a surface energy of the 4D nucleus. The proposed is 4D process responsible for the expansion, creation of matter, and error of. It is the main hypothesis of WM. In our view, the error of the cosmological time does not depend on any physical phenomenon in the medium of the world. It is the result of the 4D nucleus of the world expansion due to the driving force for surfaces to be created. It is important to emphasize that creation of matter is a direct consequence of expansion. Creation of UC matter occurs homogeneously in all points of the hypersphere world. Primary notions. Principle of relativity is the requirement that the equations describing the laws of physics have the same form in all admissible frames of reference, including inertial forces. For example, in the framework of special relativity, the Maxwell equation have the same form in all inertial frames of reference. In the framework of general relativity, Einstein's field equations have the same form in arbitrary frames of reference. In WUM, this principle is valid because the medium of the world is an absolute frame of reference. Then there is no need to discuss special relativity and general relativity, which abandoned in the ether in 1905. We can use the well-known equation considering time-varying physical parameters. Universality of physical laws is the notion that the spatial distribution of matter in the universe is homogeneous and isotropic when viewed on a large enough scale, since the forces are expected to act uniformly throughout the universe and should therefore produce no observable irregularities in the large-scale structuring over the course of evolution of the matter field that was initially laid down by Big Bang model. In WUM, this principle is valid at the cosmological times over 10 to the minus 18 seconds because physical laws are determined by the medium of the world, which is homogeneous and isotropic and consists of elementary particles with 2/3 of the total matter. The distribution of macro objects with 1/3 of the total matter is spatially inhomogeneous and anisotropic and temporally non-simultaneous. And therefore, this principle is not viable for the entire world. Conservation law states that a particular measurable property of an isolated physical system does not change as the system evolves over time. Exact conservation laws include conservation of mass and energy, conservation of linear momentum and angular momentum, and conservation of electric charge. One particularly important result concerning conservation laws is Noether's theorem, which states that there is a one-to-one correspondence between each of one of them and a differentiable symmetry of nature. Conservation of energy follows from the time invariance of physical systems. Conservation of linear momentum follows from the space translation invariance translation along x, y, z directions. Conservation of angular momentum follows from the rotation invariance rotation about XYZ axis. In my opinion, angular momentum problem is the killer of all existing cosmological models, including Big Bang model. Old timers of cosmology should solve this problem. In WUM, conservation laws are not exact conservation laws because the world is not an isolated physical system and is continuously getting, you see, matter from the eternal universe. Maxwell equations form a foundation of classical electromagnetism and gravitomagnetism. Gravity Einstein's field equations are nonlinear Maxwell equations, which should be used in a strong field limit. In Maxwell equations, there are no notions of elementary charge and energy, but there are charge density and energy density. Maxwell equations produce only two physically measurable quantities, energy density and energy flux density. The proposed new primary notions are, in fact, a paradigm shift in classical physics. Main results of WUM. Summary of the calculated by WUM in 2013 cosmological parameters and experimentally measured parameters are presented in the following table. Gravitational parameter calculated in 2013 were measured in 2018 with the same accuracy. Hubble's parameter in 2021, ionized baryons in 2016, minimum photon energy in 2017. We emphasize that WUM allows for precise calculation of values that were only measured experimentally earlier and makes verifiable predictions. I mean, MBR temperature, it was measured in 2009, and far infrared background temperature peak, it was measured in 1998, but calculated by us in 2013. The discovery of a supermassive compact object at the center of our galaxy, Nobel Prize in Physics 2020, made by Hensel and Gass, is a confirmation of one of the most important predictions of WUM in 2013. Macro objects of the world have cores made up of the discussed dark matter particles. Other particles, including dark matter and baryonic matter, form shells surrounding the cores. GWST discoveries confirmed the most important predictions of WUM in 2018. Absolute age of the world is 14.22 billion years. Dark epoch spanning for Laniakea supercluster from the beginning of world for 0.45 billion years, when only UC matter macro objects form and evolve. Luminous epoch ever since 13.77 billion years for Laniakea supercluster, when luminous macro objects, superclusters, galaxy, extrasolar system, etc. emerge. Transition from dark epoch to epoch to luminous epoch is due to explosive rotational fission of overspinning, surface speed at equator exceeding escape velocity, UC matter superclusters cores, and self-annihilation of UC particles. Macro objects of the world form from the top superclusters down to galaxies and extrasolar systems in parallel around different cores made up of different UC particles. 3M finite boundless world presents a patchwork quilt of different luminous superclusters which emerged in different places of world at different cosmological times. Explain problems. WUM solves a number of physical problems in contemporary cosmology and astrophysics through UC particles and their interactions. Angular momentum problem in birth and subsequent evolution of galaxies and extrasolar systems explained by volcanic rotational fission of overspinning UC matter superclusters cause. Hubble tension explained by observation of galaxies which belong to different superclusters. The value of Hubble's parameter should be measured based on cosmic microwave background radiation only. Missing baryon problem related to the fact that the observed amount of baryonic matter didn't match theoretical predictions solved by the calculation of the concentration of intergalactic plasma. Fermi bubbles, two large structures in gamma rays above and below galactic center, are stable clouds of UC particles, UCF1, UCF2, and UCF3, containing uniformly distributed UC matter objects in which UC particles self-annihilate and radiate gamma rays. Galaxies are ellipticals and spirals due to an explosive rotational fission of their overspinning UC matter cores. Coronal heating problem relates to a question of why the temperature of the solar corona is millions of degrees higher than that of the photosphere. According to WUM, the origin of the solar corona plasma is not coronal heating. Plasma particles, electrons, protons, multi-charged ions are so far apart that plasma temperature, in the usual sense, is not very meaningful. Plasma is the result of the self-annihilation of UC particles. The solar corona, made up of UC particles, resembles a honeycomb filled with plasma. Cores of Sun and Earth rotate faster than their surfaces, despite high viscosity of the internal medium. WUM explains this phenomenon through absorption of UC particles by cores. UC particles supply not only additional mass proportional to tau in power 3 over 2, but also additional angular momentum proportional to tau squared. Cores irradiate products of self-annihilation which carry away excessive angular momentum. Solar wind is the result of this mechanism. Internal heating of gravitationally rounded objects in solar system is explained by UC matter reactors inside of all macro objects fueled by UC particles. Internal heating is due to UC particles self-annihilation. Diversity of gravitationally rounded objects in solar system is explained by UC matter reactors inside of macro objects fueled by UC particles. All chemical elements, compositions, radiations are produced by macro objects themselves as the result of UC particles self-annihilation in their different UC matter cores. Plutonium-244, with half-life of 80 million years, exists in nature. It is not produced by the nuclear fuel cycle because it needs very high neutron flux environments. Any plutonium-244 present in the Earth's crust should have decayed by now. In WUM, all chemical products on the Earth, including isotopes Ca-40, uranium-238, thorium-232, and plutonium-244, are produced within the Earth as the result of UCF1 self-annihilation. They arrive in the crust of Earth due to convection currents in the mantle carrying heat and isotopes from the interior to the planet's surface. Expanding Earth's hypothesis asserts that the position and relative movement of continents is at least partially due to the warmth of Earth increasing. In WUM, the Earth UC matter core absorbs new UC particles, and its size is increasing in time proportional to root square of tau. Hence, there is an expansion of UC matter core, and its surface, the upper mantle with crust, is stretching. Due to UC particle self-annihilation, new chemical elements are created inside of the upper mantle with crust. As a result, the relative movement of continents is happening. Faint young sun paradox describes the apparent contradiction between observations of liquid water early in Earth's history and the astrophysical expectation that the sun's output would be only 70% as intense during that epoch as it is during the modern epoch. In WUM, all macro objects of the world were fainter in the past. As their UC matter cores absorb new UC particles, the sizes of macro objects and thus their luminosity are increasing in time proportionally to tau. Considering the age of the world, 42 billion, and the age of the solar system, 44.6 billion years, it is easy to find that the young sun's output was 67.6% of what it is today. Matter-antimatter asymmetry problem. Ordinary matter is a byproduct of UC particle self-annihilation. This problem does not arise since antimatter does not get created by UC particle self-annihilation. Black body spectrum of microwave background radiation is due to the thermodynamic equilibrium of photons with intergalactic plasma. Unidentified infrared discrete emission bands with peaks 3.3, 6.2, 7.7, 8.6, 11.2, and 12.7 micrometers, explained by self-annihilation of UC particles UC4 with rest energy 0.2 electron volts. Solar corona, geocorona, and planetary coronas made up of UC particles resemble honeycombs filled with plasma particles, electrons, protons, multi-charged ions, which are the result of UC particles self-annihilation. Lightning initiation problem and terrestrial gamma-ray flashes are explained by the self-annihilation of UC particles in geocorona. Ball lightning are objects that have cores made up of UC particles surrounded by the electron-positron plasma shells contaminated by chemical elements of soil and air as a result of terrestrial gamma-ray flash strikes of the ground. WUM predicts a new phenomenon, a generation of ball lightnings according to the proposed model of them. Once we master the creation of ball lightnings in a controlled environment, we can concentrate our efforts on harvesting that energy from a practically infinite source, the medium of the world with UC particles. Conclusion. Hypersphere World-Universe Model is consistent with all concepts of the world. The model successfully describes primary cosmological parameters and their relationships. WUM allows for precise calculation of values that were only measured experimentally earlier and makes verifiable predictions. The remarkable agreement of calculated values with the observational data gives us considerable confidence in the model. Great experimental results and observations achieved by astronomers in the last decades should be analyzed through the prism of WUM. Considering the GWST discoveries, successes of WUM, and 87 years of Dirac's proposals, it is high time to make a paradigm shift in cosmology and classical physics. Acknowledgements. I'm always grateful to academician Prokhorov and Professor Manenkov, whose influence on my scientific life has been decisive. I am eternally grateful to my scientific father, Paul Dirac, who was a genius and foresaw the future of the physics in new cosmology. I am forever grateful to Nikola Tesla, who was a genius. I am much obliged to Professor Korda for publishing my manuscripts in the Journal of High Energy Physics, Gravitation, and Cosmology. I am grateful to Nick Percival and Harry Ricker for valuable comments and suggestions, which have led to an overall improvement of the presentation. Special thanks to my son Ilya, who helped me clarify model and improve its understanding.